Okay, today we are going to look at determining the rate of change, which is related to finding the slope of a line. So the first part of this, we're going to review how to find the slope of a line. I need to move that out of the way on my screen. Let's take that, drag it over there. Okay, slope of a line. This is where people start getting confused because when we graph an ordered pair, we always graph the x first, so we always go left or right first, and then we graph the y, we go up or down second. When determining the slope of a line, we actually do it kind of in reverse, because on the top, we want to find the rise, which is the up or down, and on the bottom, we want to find the slope, or the run, which is the left to right. So the 2 points that we have here on this graph, let's just call this point A and this point B. If we were going to go to point A to point B, first of all, we would say how many do we have to go up or down? In this particular one, we would have to go down 2. When we go down the number line, the integers are getting smaller, so that's a -2 for the rise. And then we have to go over to the right, 1, 2, 3, 4, 5, 6. That is a +6. So our slope is -2/6, or we can simplify that to -1/3. Now let's say you didn't start on A, but you decided you wanted to start on point B. Would you get the same slope going from point B to point A? If you start on point B, you first have to go up a +2 because we do the rise first. So that's up a +2. Then we go to the left 6. We'll go into left on the number line, results in smaller numbers, so that's a -6. So still, it is a -2/6, which is a -1/3. So don't be concerned about which point do I start at. Doesn't matter, you're going to end up with the same slope, but you want to do the rise on the top and the run on the bottom, the up or down on the top and the left or right on the bottom. Clicker to work here. Come on. Okay, in our next example, just to show again, we have to pick a point. Let's just call this one A and this one B. Doesn't matter again which one you start with. But if I start on point A, first I want to go up or down. This particular one, I'm going up 1, 2, 3, 4, 5. That's a +5. So our rise is a +5. Then I'm going to the right 2. That's a +2. So our slope is just 5/2 or 5/2. In the next example, you will see that if we call this point A and this point B, to go up or down, we do not have to go up or down because they're on the same line. So that's 0 up or down. Then we go to the right, 1, 2, 3, 4, 5, 6, 7. That's a +7. But any 0 divided by any number is just 0. So we call that a 0 slope. If I back up here for just a minute, back up for just a second because I forgot to point something out. If you were to connect these 2 points and draw a line, you would notice that it goes downhill. When it goes downhill, this is called a negative slope. And you can see right here that sure enough, that is a negative slope because of the negative sign. So you know when it's negative, it's going to go downhill. This one, the slope, if you remember, was a 5/2, which was a +5/2. So this is called a positive slope when it goes uphill. On the one we just did, I like to think of as skiing. If you're skiing, can you ski on horizontal land, flat land? Yeah, you can see on that, but the slope that you're on is a 0. You're not going up or down, so we call that a 0 slope. On this next example, to get from point A to point B, the rise would be down, it looks like 14. That's a -14. But the run, you're on the same line, so you do not have a run from left to right. Now in math, we have a rule that says thou shalt not divide by 0. So let's think about this. If you were to take 5 stars, theoretically, and you try to divide them into 0 groups. This would be 5 divided by 0. Well, these 5 stars exist. You can't put them into 0 groups because even if I leave them the way they are in one group. It is impossible to take things that exist and divide them into 0 groups. You cannot divide by 0, so we call this line undefined. Again, if you think about it as a snow skier, this was a 0 slope. You can do that. You can do a 0 slope as a skier, but right here, if you were skiing, this would not be skiing, this would be falling to your death. So you can't do that in skiing, so we call that undefined. If that helps you remember which one you can do and which one you can't do, think about a skier. You can't ski that slope without probably killing yourself. So as review, look up here, we decide if each line is a positive, a negative, a 0 or undefined slope. This one is a positive slope because it goes uphill. This one, again, if you think about a skier and you're trying to ski the slope, skiing straight downhill off a cliff, probably wouldn't work too well. So we call that undefined. This is your 0 slope. That means you're skiing, but there's no slope at all, just flat ground. And this would be our negative slope because it's going downhill. Now that was all background to take to our next step of finding the rate of change. Why learn this? Rates of change can be used to quickly find out how much costs have increased or decreased. This is used in a lot of businesses when they're trying to see if their business is being profitable, if their business is declining, which part of the company is doing well, which part of the company is doing poorly. They can find the rate of change. So an example of how this works. In 1985, the cost of sending a 1-ounce letter was 22 cents. In 1988, the cost was 25 cents. How fast did the cost change from 1985 to 1988? If you think back a couple of lessons, we had to figure out which was the independent and which was the dependent variable. And we said that the x was the independent and the y was the dependent variable. So if we were to put this into a table, we think, is the cost dependent on the year, or is the year dependent on the cost? Well, with a cost is dependent on the year. So that makes the cost the dependent variable, which goes in the y, 22 cents and 25 cents. And the independent would be the dates, which are 1985 and 1988. So all I did was take that information and arrange it into a table. So now you have ordered pairs. You can see the ordered pair here, your x and y ordered pairs. You have the ordered pair 1985 and 22, and you have the ordered pair 1988 and 25. So you could graph those 2 points on a graph. But today we're trying to find slope and rate of change. And to find slope and rate of change, we are going to subtract the y's on the top, or the dependent variable, and the x's on the bottom, which flips the way it was presented in the table. Because remember, in a table, the x is on the top and the y is on the bottom. So when you set this up, you have to think, okay, I've got to subtract the y's on the top, or the dependent variable. The years were dependent, I'm sorry, the cost was dependent on the years. I think I just said that wrong. In our table that we just had, we had the years up here in the x, 1985 and 1988. It will help me just to draw it out. So that was our independent, remember, I'm reminding myself. And the y, the dependent variable, was the 22 cents and the 25 cents. So we want to subtract the y's on the top. So our y's were 22 and 25. Now, which do you do? Do you do 22 minus 25, or do you do 25 minus 22? Let's try both. If we do 22 minus 25 on top, subtract the y's on top, now we have to subtract the x's on the bottom. We want them to go in the same order. So since 22 came first, we have to do the 1985 and subtract the 1988. Now, if we did this, on top you have a negative 3, on the bottom you have a negative 3, which results in a slope of 1. If we were to flip that, and we were to say, okay, I'm going to subtract 25 minus 22, since I did the 25 first, I have to do the 1988 first. Well, when you subtract, you get 3 divided by 3, which also results in the slope of 1. You get the same slope. So as long as you're consistent, usually they say y2 minus y1, but as long as you're consistent, you're going to result in the same thing. What I want us to do now is look at your notes. This is where we actually are starting to take our notes today. And we're going to add to this table. Here you'll see a table. And of course, when you have a table of information like this, the top is the x, the bottom is the y. So the top is the independent, and the bottom is the dependent. But it's just asking you to find the rate of change in cost for each time interval. So to do that, when it asks for 1988 to 1990, we look at these two sets of information. We're going to subtract the y's on the top and the x's on the bottom. So on top, we're going to do 25 minus 25, 1990 minus 1988, which results in a slope of 0 divided by 2. That means if we were to graph this, we would go up 0 and over 2, which of course makes a 0 slope. Now, to find the rate of change, this is the slope. Today, we're going one step farther, finding the rate of change. After you figure out the slope, after you subtract the y's on the top and the x's on the bottom, to find the rate of change, you're just going to take your calculator and you're going to do this division. It says 0 divided by 2. Well, of course, 0 divided by any number is 0, so it changed 0 cents per year. Now let's look at the next time interval of 1990 to 1991. So now we're looking at these two bits of information, subtracting the y's on the top and the x's on the bottom. I'm going to do 29 minus 25 at 91 versus 90, which gives us a slope of 4 over 1. That means we rise 4, go to the right 1. But again, that's the slope. To find the rate of change, we go one step farther and go, what is 4 divided by 1, which means it changed 4 cents in 1 year. For the next interval, we go to 1991 to 2004. We subtract the y's on the top and the x's on the bottom. So we have 37 minus 29 on the top, 2004 minus 1991 on the bottom. That results in a slope of 8/13, which means you rose 8 and went to the right 13. That gives you the slope. But in order to find the rate of change, you go that one step farther, take your calculator, go 8 divided by 13, and you will find out that it changed 62 hundredths of a cent per year, which is less than 1 cent per year. In our last time interval, we have 2004 to 2008. Again, we subtract the y's on the top and the x's on the bottom. So we have 42 minus 37, which gives us a slope of 5 divided by 4. We rose 4, went to the right 4. Rose 5, went to the right 4. If we were to actually go that one step farther and determine the rate of change, we would take our calculator, we would go 5 divided by 4, and we would find that it changed by 1.25 cents per year. Now companies could look at that and they could ask themselves, when was the greatest increase, when was the smallest amount of increase, and find reasons why that was true. The cost increased the greatest between 1990 and 1991 when it was a 4-cent per year raise. We could graph that. Now, if you look back at the table here, remember, these were some ordered pairs right here. These were ordered pairs that we could graph x, y. So in this next graph, you will see that I've graphed those 5 order pairs. Here was the 1988 with 25 cents. This was the 1990 with 25 cents. And these were the next 3 order pairs. To show this what this looks like graphically. Between the first 2 intervals, we had a slope of 0. They both were at 25 cents. Between the next interval, we rose, it looks like 1, 2, 3, 4, and we went to the right 1, so our slope was 4 over 1, which gave us a rate of change of 4 cents per year. From there, this line shows us our rate of change after we went up from 29 cents to 37 cents, which was an increase of 8 on the rise and 13 on the run. That rate of change was 62 hundredths of a cent per year. And then here was our last one. So you can just see how that is graphed. And you can even tell by looking at the graph where the greatest increase was because it has the steepest line. And if you were going to look for where the least amount of increase happened, you would look for the flattest line, which of course is our zero slope right here. So this is the kind of thing we're going to be doing our assignment today. Just remember to find slope. You have the rise on the top, the run on the bottom. If you're finding the slope of 2 points, you're going to subtract the y's on the top, subtract the x's on the bottom, and then do the division to find the rate of change. I hope this helps doing your assignment.